Upon learning the basic or general concepts of the ideal gas law, we'll be having a 4 video series about how we're going to apply the gas law formulas um, with basic problems. So this video will be the first of the series. It will be about chapter 1, solving ideal gas problems. PV is equal to nRT. This is going to be the formula that our problems will revolve around. So without further ado, let's start. Now you have to recall, by the way, the variables. Let's dissect the formula into pieces. We have pressure, volume, mole, Raoult's constant, temperature. Altogether, PV is equal to nRT. So we have to acknowledge that the default unit for pressure is atmosphere, or abbreviated as ATM. For volume, our default unit is liter. For mole, it's still mole. I'm not sure about the abbreviation for this, but then it looks like it's basic, so you just write mole anyways. For Raoult's constant, the formula would be, the default unit would be latum over nk. Liter times atmosphere, altogether divided by the mole times Kelvin. And hence, about Kelvin, it's the default unit for temperature. So, you might ask why we still need to take note of the corresponding default units of the variables. In case that the problem states the quantity of a variable that is not the default unit, well, the process of conversion is required. Otherwise, your answer will be different because the computation only works when the quantities are based on the default units as stated here. So let's start with number 1. By the way, it says here in the instructions, apply GRESA. This is basically a technique for solving science problems that require the given, required, equation, solution, and the answer. So yes, let's start with number 1. The pressure, volume, and temperature of a gaseous sample are 0.73 atmosphere, 1.68 liters, and 22 degrees Celsius respectively. We have to determine the number of moles of gas in the sample. So first, let's enumerate our given. So PV is equal to nRT. Our pressure is 0.753 atmosphere. Why? Because the unit, it's quite obvious already. Once you see the unit atmosphere, it's already understood that the quantity is pressure. So for liters, we have 1.68, the volume. For the mole, exactly, that's what we're trying to find. So determine the number of moles of gas in the sample. So this is a question mark. For Raoult's constant, I suppose I've mentioned this in the previous video about the general concepts of the ideal gas law. The Raoult's constant, the quantity is never changing. Literally, it's a constant. 0.0821 latum over nk. This is m, by the way. I'm sorry for the bad handwriting. For temperature, we have 22 degrees Celsius. Now, everything enlisted in the given have default units except temperature. As stated earlier, the default unit for temperature is Kelvin. Now, we have to convert temperature, convert Celsius to Kelvin. So, also in the previous video, we've talked about the temperature conversion formulas, one of which are important right now. One of which is important right now. Kelvin is equivalent to degrees Celsius plus 273, such that our degrees Celsius is 22 degrees Celsius. You're going to need a scientific calculator. I don't think it's prohibited when solving these kinds of problems, but still, it depends on your teacher whether he or she allows or prohibits the use of scientific calculator when solving these problems. But anyways, as for my teacher, he allows scientific calculator, so we'll be basing on that kind of school of thought. 22 plus 273. I hope you have your scientific calculators with you. Let's solve together. So temperature is 295 Kelvin. Now, for our equation, now that we have the complete values, everything is already ready for being substituted in the formula. Let's base our equation. Let's start with PV is equal to nRT. Now, what we're trying to find is mole, this one. So let's apply the concept of literal equations in elementary algebra. Let's just copy this, then divide both sides by RT to leave alone the mole at the other side. So N is equivalent to PV over RT. This is our equation. Now let's move on to our solution. For our solution, mole, let's substitute the values now. Pressure 0.753 atmosphere times our volume, which is 1.68 liters, all together divided by our Raoult's constant 0.0821 latum over nk times our temperature, which is 295 K. We're not going to use the quantity that's in a different unit. It should always be in the default unit. And in terms of temperature, it's Kelvin. Now, use the scientific calculator again. Fill in the values. These, place it, and we get 0.05223229216. Now, it may be overwhelming at first, but I don't think it's not allowed to round our decimal to 5 digits. I'm not sure if I said that correctly, but with what I'm doing right now, I hope you understand it. So 0.05223, we have 5 digits after the decimal point. And don't forget to place the unit value, which is mole. So this is our final answer. So that's everything for this video. Just one example. I hope you're able to understand it. Especially you have to take note of this. And this may also serve as a structure to organize your solution. Especially now that we're going to have lessons about the three laws, the combined gas law, Boyle's law, and Charles's law. So that will be chapters 1, 2, and 3. 2, 3, and 4 respectively. So I'll wait for that video. It won't be long. Thank you.